Hello students, today we are going to discuss exercise solution, that is it is our question answer session which is related to chapter number 4, materials, metals and non-metals. Okay, so be ready with your notebook, with your pen and book. Okay, so let's start. Question number 1. Which of the following can be beaten into thin sheets? So tell me, they have given here 4 options: zinc, phosphorus, sulphur, oxygen, and answer is zinc. Why zinc option is there? Because zinc is metal and phosphorus, sulphur, oxygen, these all are non-metals. So we have to revise one property of metals, that metals are malleable. Means if we beat metal with a hammer, they can beaten into a thin sheets. This property we known as malleable property of metals. Okay, so zinc is a metal and metal has a malleable property, or metal shows malleability, means they can be turned into thin sheets. Okay, and that's why A option is correct one. Which of the following statement is correct? They have given 4 options. All metals are ductile, all non-metals are ductile, generally metals are ductile, some non-metals are ductile. Option C is correct one. Let's discuss why this option is correct. So all non-metals are ductile and some non-metals are ductile. These two options get cancelled because non-metals not showing any property of ductility. Okay, so B and C get cancelled. All metals are ductile and generally metals are ductile. What is the difference between these two statements? Okay, so not all metals are ductile. When we studied this topic, that time also I mentioned that most of the metals are ductile. Okay, so because of that, generally metals are ductile, not all metals are ductile. Okay, so because of that, C option is correct one. Okay, yeah, we discuss other properties also, means most of the metals are hard to touch, but some of the metals are soft also. Most of the metals are solid at room temperature, but some of the metals are liquid also. Okay, most of the metals are, means they are good conductors of heat and electricity. Not all metals showing same property. Okay, there is also variation between the properties also. Because of that, C option is correct one. Generally metals are ductile. Next, filling the blanks. Phosphorus is very dash dash non-metal. Phosphorus is very reactive non-metal. Okay, because when phosphorus comes in a contact with atmospheric oxygen, they will catch fire. Okay, so if we place phosphorus as it is, they will catch fire. So it is related to the reactivity. That's why we kept phosphorus in kerosene. Okay, so here reactive. Metals are dash dash conductors of heat and electricity. Yes, good conductors of heat and electricity. Iron is more reactive than copper, or copper is less reactive than iron. Okay, so here iron is more reactive. Metals react with acids to produce which gas? Hydrogen gas. Yeah, have you remembered that pop-up sound when we place matchstick over the test tube in which hydrogen gas is there? That time pop-up sound will create. Okay, so metals react with acid to produce hydrogen gas. Next, mark T if the statement is true and mark F if it is false. First one is, generally non-metals react with acids. Non-metals not showing any reactivity with acids. Okay, so for this statement is false. So here F is here. Sodium is very reactive metal. Yes, statement is true. Because of that we put here T. Sodium is very reactive metal. Yes, and because of that when we place sodium as it is in the atmosphere, it will react with atmospheric oxygen, atmospheric moisture or water, and that's why they catch fire. Okay, so it is very reactive metal. Okay, copper displaces zinc from zinc sulfate solution. This we studied in our displacement reaction. Copper is less reactive than a zinc. And what is the definition of displacement reactivity or displacement reaction? More reactive metal replaces or displaces less reactive atom. Okay, so here copper is less reactive than zinc. Yes, and how it will displace zinc? No, statement is wrong. Yes, that's why we put here F. Coal can be drawn into wires. Coal is a form of carbon. Carbon is non-metal. Yes, and non-metal not showing any property of ductility. Yes, and if we hammer or if we beat coal with a hammer, what will happen? The coal pieces broken down. Coal is broken down into a several pieces, so they will not drawn into a wires. That's why the statement is false. Getting? Okay. Next, some properties are listed in the following table. Distinguish between metals and non-metals on the basis of these properties. Okay. Tell me one by one. Appearance of metal. Tell me, it is shiny. And appearance of non-metals, dull. Hardness, most of the metals are hard to touch and non-metals are soft one. Malleability, metals are malleable, non-metals are non-malleable. Ductility, metals are ductile, non-metals are non-ductile. Heat conduction, metals are good conductor of heat and non-metals are poor conductor of heat. Conduction of electricity, metals are good conductor of electricity, non-metals are poor conductors of electricity. Okay, so fill this table. Okay, write down. Metals are shiny, non-metals are dull. Hardness, metals are very hard, non-metals are hard or soft. Both property they have showing. Malleability, metals are malleable, non-metals are not malleable. Ductility, metals are ductile, non-metals are non-ductile. Heat conduction, conductor of heat, non-metals non-conductor of heat. Conduction of electricity, conductor of electricity, non-conductor of electricity. Here one. Okay, metals, non-metals are hard to touch. We studied the one exception for this is diamond. Diamond is a form of carbon and it is the very hard non-metal in a which found in a nature. Okay, give reason for the following. Aluminium foils are used to wrap a food atom. Okay, why? First tell me, aluminium is metal or non-metal? Yes, aluminium is metal. We discussed. They have the property like they are shiny. Okay, they are hard to touch. Because aluminium is metal, it shows the property like they are highly malleable. So it can be easily bitten into sheets to make its foil for wrapping purpose. Okay, so aluminium, it is also soft one, means when we make foil from it, it converted into a soft form, And aluminium, it does not react with a food atom. This is most important. If it will show any reactivity with a food atom, no one can use aluminium for wrapping purpose. Okay, so it does not react with the food atoms. Yes, and because it is a metal, so metal have another property, that is they are good conductor of heat. So they will maintain the temperature of food atom intact as it is, because it will pass the heat throughout the food atom. So food atom maintain intact or as it is, and that's why food is if we wrap food atom in a aluminium foil, it maintain its temperature. Okay, so because of this, aluminium foils are used to wrap food atom. Getting? So here highlighted one is aluminium is metal, so it is malleable. It can be turned into a sheets, so we can make a foil from it. It is soft one and does not react with the food atom, and it maintain temperature of food intact, so it is good for wrapping food atoms. Okay, next, immersion rods for heating liquids are made up of metallic substances. Okay, so immersion rods, what they mention, it is made up of metallic substances. So as we discussed earlier, metals are good conductor of heat and electricity. Okay, and because of that, they get hot very soon on the passage of electric current and warm the water. That is why immersion of rods are made up of metals. Okay, so here they have used two properties, that is the metals are good conductor of heat and electricity. So when electric current pass over the liquid solution in which we place immersion rod, they will circulate electricity all over the water which is there inside the container, and that water which is there in a container, that will get warm very soon, and that's why we used metallic substances for making immersion rods. Copper cannot displace zinc from its salt solution. Tell me the answer. Copper is less reactive than a zinc, as we discussed earlier and in this session also. Copper is less reactive than zinc, so it cannot displace zinc from its solution. Okay, we will move to next question. Sodium and potassium are stored in kerosene. Okay, why? Because sodium and potassium are highly reactive. When it comes in a contact with air or water, they catch fire very quickly, and to avoid this or to prevent this reaction, we placed sodium and potassium in a kerosene. Getting? Okay. Question number 7. Can you store pickle in an aluminium utensil? Why or why not, you have to explain. Okay, so answer is no. Why? Because lemon pickle, if we store in an aluminium utensil, because aluminium is a metal. Okay, and as we already know that metals really react with the acids, and when metals react with acids, they produce hydrogen gas. Okay, so when aluminium comes in a contact with the lemon, and we know that lemon has acid in it. Okay, so when it comes in a contact with the aluminium metal, it will react, sorry, the reaction will takes place. Why? Okay, and in this reaction, what will produce? So hydrogen gas will produce, and because of that, pickles will be spoiled. Okay, getting? So we cannot store pickle in an aluminium utensil. So where we can store pickle? In a glass container. Okay, so the reaction will not takes place and pickle will not be spoiled. Okay, getting? So read this twice or thrice and write down in your notebook. Okay, next, match the substances given in a column A with their uses in column B. So gold, match the substances in a column A, and here in column B they have given its uses. So gold, where we use gold? For making jewellery. Iron, yes, iron is strong metal, so we can use iron for making machinery. Aluminium, yes, aluminium has a good use in a packaging purpose, so aluminium we can use to make wrapping food. Carbon, yes, carbon is a non-metal and they have uses in a fuel industry. Okay. Copper, yes, copper is good conductor of electricity, so electric wire we can make by copper. Mercury, mercury is a metal which is liquid at room temperature, so mercury has use in thermometer. We can use mercury to make a thermometers. Okay, next, so here answer gold, jewellery, iron, machinery, aluminium, wrapping food, carbon, fuel, copper, electric wire, mercury, thermometer. What happens when dilute sulphuric acid is poured on copper plate? What will happen? Yes, we discussed that copper is very less reactive and that's why no reaction will takes place. Getting? Iron nails are placed in a copper sulphate solution. Iron nails are placed in copper sulphate solution. Okay, write word equation of the reaction involved. So in a beaker, imagine copper sulphate solution is there, and in that beaker if we place iron nails, what will happen? Iron being more reactive than copper, yes, because copper is very less reactive, iron is more reactive than copper, will replace copper from its solution. Yes, just revise the definition of displacement reaction. More reactive metal will displace less reactive metal. Okay, so iron is more reactive, that will replace copper, okay, from its solution. And brown coating of copper, what? Brown coating of copper is deposited on iron nails. Also the blue color turns green because copper sulphate has a blue color. Copper sulphate is a blue color solution, has a blue color, so that blue color turns into green. So it is a identical reaction. Okay, so iron plus copper sulphate, it is the word equation of this reaction. Iron plus copper sulphate, what will happen? Iron replace copper. So what is our product? Iron sulphate. Iron sulphate. Okay, and color of the solution is now green. Okay, and copper replaced out. Getting? Iron plus copper sulphate solution, copper sulphate solution has a blue color, that will form iron sulphate, green color solution, and copper. Okay, next, 10 number question. Saloni took a piece of burning charcoal and collected the gas involved in a test tube. Okay, so how will she find the nature of the gas? Getting? and B is write down word equations of all the reactions taking place in this process. Okay. When charcoal is burned in air, charcoal is also a form of carbon. So when it is burnt in air, the gas is evolved. This gas is known as carbon dioxide. So if she um, collect that gas in a test tube, okay, so for that, to check out nature of this gas, she has to wet the litmus paper and she has to check this nature of gas by this litmus paper. So for checking the nature of gas, she has to use a wet litmus paper. Okay, so after bringing the litmus paper in contact with the gas, if it turns blue litmus paper into red, it is acidic. Similarly, if it turns red litmus into blue, it is basic. And this gas, when passed into a lime water solution, it turns milky. This is the test for gas. Okay, so equation is carbon plus oxygen. It is carbon dioxide, because carbon means charcoal. If she burn charcoal, means a carbon plus oxygen, which gas will produce? Carbon dioxide. Okay, and this carbon dioxide, if we pass into a lime water, if it turns milky, this is the test for the carbon dioxide gas. Okay, next is question number 11. One day Reeta went to a jeweler's shop with her mother. Her mother gave an old gold jewellery to the goldsmith to polish. Next day, when they brought the jewellery back, they found there was a slight loss in its weight. Can you suggest a reason for the loss in weight? Okay, when we give a jewellery for polishing, what will happen? The gold jewellery is dipped into a mild acidic solution. That solution we called as aqua regia. This aqua regia is the acidic solution, and that is the mixture of two acids, hydrochloric acids and a nitric acid. Okay, so on dipping the gold jewellery in this acidic solution, the outer layer of a gold dissolves and inner shiny layer appears. This causes a slight loss in its weight. Okay, the metals have the appearance that they are shiny. Shiny means sometime, if we take example of copper. Okay, so in this is a daily life example, that when we use that copper vessels for our puja purpose. Okay, so what our mama does, she will she will make that copper shiny by polishing that copper with pitambari. Okay, so pitambari or any acidic means we can use a lime, we can use a kokum plus salt, we can use tomato plus salt. So it will create a acidic solution. So because of that acid, the outer layer of that copper gets out from it, and the inner layer, which is a shiny one, will appear. So when we make a metal shiny, that time with acid, that time some part of that metal will removed out from that metal surfaces, and because of that, the layer which is inner side, which is shiny one, that appears on the outer part. Okay, and that will cause a loss in that metal. And the same case will happen over here in polishing the gold jewellery. We have to dip that gold jewellery into an acidic solution. Like in a copper, we use a lime, or we use any acid means kokum or tomato, so that will make a acidity. Okay, so a mild acidic solution which is called as aqua regia. Aqua regia is a mixture of hydrochloric acid and a nitric acid, so it is an acidic solution. And when we um, acidic solution when comes in a contact with the metal surfaces, that time the shiny layer which is inside that will come out and the outer layer dissolves. Okay, and that's why there is a slight loss in its weight. Okay, so thank you so much. So up to 11 question we discuss all the questions of this topic. Okay, so write this question and answer in your notebook. Okay, thank you. And revise all the questions, it is very important. Revise all the topic, that physical properties of metals and non-metals, chemical properties of metals and non-metals, and its uses. Okay, thank you so much.